Hello students, let's go over motion and free body diagrams. So first thing you need to do is identify the system. We do that by drawing a circle around the object that we're interested in. And what we're going to do here is we want to be able to draw a motion diagram, also known as a dot diagram. And we need to indicate the direction of the acceleration and velocity and draw vectors of appropriate lengths. And then 3, we're going to draw free body diagrams. And in order for us to do that, we want to be able to label all the forces with their agents, and we want to draw vectors of appropriate lengths. So let's take a look at this example. So this athlete is accelerating in a positive direction. So we identify the object in question, and we draw a circle. Let's take a look at how the motion diagram looks. This is a motion diagram for this scenario. We see that velocity is increasing because the particles, the dots, are getting further and further apart. So velocity is increasing. And when velocity is increasing, that means acceleration. There is acceleration. So we draw the acceleration vector. Now let's take a look at the free body diagram. So we know that this object is running and there is the force of gravity acting on it. There is also the force of the ground. This is also known as the normal force. Now these vectors are the same length because the object is not floating up and it's also not falling. It's kind of just staying stationary in a vertical direction. Now we have the force of the push. This is also known as the applied force. And maybe there's a little bit of air resistance as this athlete is running through the atmosphere or running at a track.